Okay, so we're going to do a quick review on procedural operations of fractions. Again, this is going to be focused on the procedures. We've already talked about the concepts in class. Now I just want to make sure that we can actually do it and perform it. So we're not going to talk too much about the conceptuals. That being said, let's go ahead and take a look at the first things we're going to look at, which is addition and subtraction of fractions. What's important to remember when we do this is that we need to make sure that we have common denominators. Okay. If we don't, we need to make sure we find the lowest common denominators. Or the LCD. Oops, LCD. Then after that, all we need to do is just add the numerators, or subtract numerators, and then keep the denominators the same. And then we simplify. Okay, so let's say that we have I don't know, let's go ahead and say 2/5 plus 1/3. Okay, they do not have common denominators. Since they don't, we need to make sure we find it. And to do that, we're just gonna go ahead and list the multiples. So I'm gonna go ahead and start listing the multiples of 5. Okay, 5 is gonna be 5, then 10, then 15, 20, 25. Okay, and I'm going to do the same for the 3 now. Okay, so the 5 and the 3 were the original denominators here. So I'm going to do the same for the 3. Okay, so we start 3, 6, 9, 12, 15. Okay, well, do we have any common denominators yet? And I'm noticing right now that 15 is going to be the lowest common denominator. Okay, so for that, we're going to go ahead and make equivalent or equal fractions to 2/5. Okay, so let's see, so 2/5, I need to get a denominator of 15, and to do that I know that 5 times 3 is 15, so I'm going to multiply by the giant 1 of 3/3. 2 times 3 is 6, 5 times 3 is 15, so 2/5 is equal to 6/15. I'm going to go ahead and do the same thing now for 1/3. And let's go ahead and use a different color. So that was 2/5 was in the red, 1/3 is going to be in the green here. 1/3 times 1, 2, 3, 4, 5. 3 times 5 is 15, so I'm going to multiply the giant 1 5/5. 1 times 5 is 5. 3 times 5 is 15, so 1/3 is equal to 5/15. So I'm going to go ahead and rewrite our addition as now 6/15. That was the 2/5 plus 1/3. Oops, not 1/3, I'm sorry. We're rewriting the 1/3. So 3/5 plus 5/15. Okay, that was the 1/3. It's now 5/15. Okay, and we just go ahead and now we add the numerators. That's our next step. 6 plus 5 is 11, and then we keep the denominators the same. So essentially 2/5 plus 1/3 is equal to 11/15. 11/15. Okay, with multiplication of fractions, we learned this by looking at parts of parts. Okay, and really what we learned when we did that is when we multiply fractions, we just need to multiply the numerators and multiply the denominators. Okay, So let's actually look at the same fractions, but instead of adding that we did before, let's go ahead and multiply it. So we're going to multiply 2/5 times 1/3. Okay, numerators 2 times 1 is 2, 5 times 3 is 15. So that's all there is to multiplying fractions. We multiply 2 times 1, the numerator, 5 times 3, the denominator, and we get the fraction. There's in this case, we don't need to simplify, so we're all done. The product would be 2/15. Okay, the next thing we're going to look at is division of fractions. The division is probably the most complicated one, and we looked at the area models or diagrams, but to do this procedurally and more fluently, we're going to think more arithmetic, and we're going to think the supergiant ones. Okay, so I'm going to use a different actually, let's go ahead and use the same fractions again. I'm sorry, the same fraction. So we're going to go ahead and divide 2/5 divided by 1/3. Okay, the first thing I'm going to do is set up a super fraction. Where the dividend is going to be the numerator, 2/5, and the denominator is going to be the divisor, 1/3. Okay, so we just set up the division as a fraction. We have the super fraction. If we remember, we have to the strategy was we're going to make the denominator 1, and to do that we have to multiply the denominator by the reciprocal of the denominator. The reciprocal of 1/3 is 3/1. So I know that 1/3 times 3/1, the reciprocals, is equal to 1. So this is going to be the supergiant one now. Okay, if the denominator is 3/1, the numerator also has to be 3/1. So this is the supergiant one. 2, and then now we just multiply the numerators. 2 times 3 is 6. Let's go right here. 2 times 3 is 6. 5 times 1 is 5. Okay, so we have the fraction, the super fraction, 6/5/1. That's just equal. Anything over 1 is just the same thing, the numerator, 6/5. And if we simplify that, we're going to get 1 and 1/5. So the quotient is 1 and 1/5. Okay. Many of you guys also remember that when you divide fractions, you could just multiply by reciprocal of dividend. So looking at the same expression, 2/5 divided by 1/3, a lot of us realize that here in this supergiant 1 strategy, we're really just multiplying, switching the division to multiplication. So, so 2/5, and then the division is going to be multiplication times the reciprocal of the dividend. The reciprocal of 1/3 is 3/1, and we just multiply that out. 2 times 3 is 6. 5 times 1 is 5. We get the same answer, and that equals 1 and 1/5. Okay. So far we've only looked at fractions that are I guess more typical fractions where the numerator is smaller than the denominator. Well, what happens if we look at mixed numbers? Okay, or when we work with mixed numbers. When we work with mixed numbers, generally the strategy is to go ahead and convert mixed numbers to improper fraction. Okay. Addition and subtraction is a little weird, but sometimes only for addition can we always use this strategy. We can work with whole numbers and fractions separately. Okay, it works with subtractions sometimes as well, but we're really not going to focus on that. Generally speaking, a strategy that's going to work for everything, and that's why I'm going to go over just this one strategy, is to just simply convert the mixed numbers to improper fractions. So let's see. So if we're going to go ahead and let's just do, I don't know, multiplication. If I'm going to multiply 1 2/3 times 4 3/5, oftentimes what's going to happen is our students will multiply the whole numbers 1 times 4 to get 4, and then 2 times 3 to get 6, and then 3 times 5 to get 15, and they do the simplifying, but that's incorrect. You can't just multiply the whole numbers. You have to convert to the mixed numbers. That's what we're going to do first. So 1 2/3, okay, as an improper fraction is 1 times 3 is 3 plus 2 is 5. We have 5/3. 4 3/5, we are going to go and convert. Let's see, 4 times 5 is 20 plus 3 is 23 over 5. Okay, so these are the improper fractions we're going to work with. We're going to rewrite this expression as improper fractions. So we're going to have 5/3 times 23/5. I'm noticing now I really should have used simpler numbers, but let's go ahead and look at this. From here, we're just going to multiply fractions like normal now. Let's see, 5 times 23, I'm going to go ahead and work that out on the side here. 3 times 5 is 15. 5 times 2 is 10, plus 1 is 11. So we're going to have 115 over 3 times 5 is 15. Okay, and to simplify this, we're going to go ahead and do long division. Okay, this doesn't really help too much, I guess, but 1, 2, 3, 4, 5, 6. I believe 7 times the most is going to go. 15 times 7 is going to be 35. 1 times 7 is 7, plus 3 is 10. So looks like it's going to be 7. 7 times 15 is 105. Subtract that, we're going to have a remainder of 10. Okay, and that means we're going to have 7 wholes and 10. Okay, that's the remainder. 15ths, which simplifies as 7 2/3. Okay, and if you know how to simplify this before you multiply, you could do that. But again, as far as working with mixed numbers, you want to convert the mixed numbers to improper fractions.